ചാപ്റ്റർ സ്റ്റുഡൻസ് ഗ്രാജുവേറ്റ്സ് ആണോ ഗ്രാജുവേറ്റ്സ് ആണോ കൂടുതലും? ഓക്കെ ഓക്കെ ശരി ശരി ഓക്കെ ഓക്കെ തുടങ്ങാറായില്ലേ? ഓക്കെ 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 ഓക്കെ
Good afternoon, everyone. Hearty welcome to the national webinar on the topic Role of Quantitative Tools in Social Science Research, organized by the Department of Mathematics in collaboration with the Internal Quality Assurance Cell, St. Aloysius College, Thrissur. Here we have with us many academicians, research scholars, and students. Thank you, everyone, for taking time to join us today. Let's begin the session with a silent prayer. Thank you. Now, I invite Ms. Christina PJ, faculty in the Department of Mathematics, to deliver the welcome address.
Good afternoon to all. It's a moment of pride to welcome all of you who are present here to attend the one-day national webinar. On behalf of St. Aloysius College, I welcome our guest of the day, Dr. K.P. Mani, former professor and head of the Department of Economics, University of Calicut, our principal, Dr. Chaco Jose, head of the Department of Mathematics, Lieutenant Jason Jacob, and Head of the Department of Economics, Dr. Jesse John K. I also welcome all the teachers, students, and all the participants who have gathered here. The webinar will focus on the topic role of quantitative tools in social science research. The main objective is to analyze the relevance of mathematical and statistical tools in empowering the quality of social science research. We believe that everyone will be able to make use of the webinar. Once again, welcome you all to this session. Thank you.
Thank you, Ms. Christina, for the welcome note. We are grateful to have Dr. K.P. Mani, former professor and head of the Department of Economics, University of Calicut, as our resource person. I request our principal, Dr. Jaco Jose, to share a few words about the event and to introduce the speaker.
Thank you. I'm extremely happy and privileged to introduce Dr. K.P. Mani, former professor and head, Department of Economics, University of Calicut at Dr. John Mathai Center. Dr. K.P. Mani started his economics journey from Dr. John Mathai Center when he did MA Economics from Dr. John Mathai Center with mathematical economics and econometrics as his specialization. After that, he taught in the Kerala Agriculture University. He was with the Kerala Agriculture University as professor for around 20 years. And later, he joined the University of Calicut as professor in the Department of Economics. Dr. Mani is known for his econometric analysis of economic issues. So when the Department of Mathematics of our college wanted to have a resource person on the topic, the use of mathematical and statistical tools in economics, I had only one name to suggest. The basic idea I understand is to familiarize the students of mathematics and statistics of the uses of quantitative tools in social science research, because I think the organizers had a feeling that though social science students and research scholars often use quantitative techniques and statistical tools in their research, science students quite often do not use that. So they have no idea that statistical and mathematical tools are widely used in social science research. Besides, we have many programs in India and abroad where Master of Science in Economics is offered, where mathematics students are given preference, statistics students are given preference for admission. So I think it is to bring in this awareness of the use of mathematical tools and statistical tools in economics. This session is being organized. Dr. K.P. Mani is a very experienced research guide with more than 30 scholars being awarded PhD under his guidance. But the number of students or research scholars who have benefited of his knowledge in econometrics when compared to this formal number of 30 is much, much higher, could be even hundreds. So Dr. Mani is bringing this experience today to explain the use of quantitative techniques in social science research. And on a personal note, I'm extremely happy to have Dr. Mani here because he's the person whom I consider as my mentor. So I'm extremely happy to introduce Dr. Mani. Thank you.
Thank you, sir. So without any further delay, let's begin the session. I request all the participants to turn off their mic. If you have any queries, you can ask them at the end of the session. Now, with immense pleasure, I invite Dr. K.P. Mani to take over the presentation.
Thank you, Dr. Jesse. Very dear Dr. Chaco, Principal, Mathematics Head and Faculty, Dr. Jesse, and the other faculty members who are attending the session, very dear students. I was told that the session is attended by BSc or MSc mathematics students, statistics students, economics students, maybe management, MBA, sociology, psychology. These students may also be listening to me. See, the title of the presentation today, it is the role of quantitative tools, or you can put it as quantitative techniques. See, the title is very, very interesting. Those who are attending me, they are either graduate or postgraduate in mathematics, statistics, economics, and so on. But I am sure that none of you are a graduate or a postgraduate in quantitative techniques. Because as far as my understanding, not a single institution is offering a degree or post-graduation in quantitative techniques. So let me start by what is meant by this term, quantitative tools. Because when I interact with the teachers, particularly mathematics and statistics teachers, even commerce and economics teachers, they used to raise this question, why this title, quantitative techniques? Of course, we cannot give a very, very precise and scientific definition for quantitative techniques, but in a very, very loose way, we can put it as it is an integration of mathematical techniques, statistical techniques, operation research techniques, and also computer aided designs. So all these together can be the subject matter of quantitative techniques, or what we call it as quantitative tools. So when we use the term quantitative tools, we touch upon all these topics, mathematics, statistics, or computer, and the allied related areas. Then the science students learn all these in their classrooms. And if you focus to your learning, mathematics or statistics students, what I feel is you learn a lot of abstract mathematical theories without bothering about its relevance to the society. In earlier days, the mathematics learning was centered around very, very complicated derivations. But today there are some changes in the teaching style of mathematics also. When coming to the social science, what is interesting is economics students, sociology students, psychology, management, etc. All these students apply these mathematical techniques without knowing what it is. I'm not blaming anybody, but majority. We apply these techniques without knowing what it is. And majority of our social studies students are worried about its interpretations. So on both sides, there are problems. mathematics and statistics people, they are more concerned with abstract derivations without bothering about the society. Science researchers and students, they are applying these tools with a semi-knowledge, I put it as semi-knowledge, to the real life or society, and they don't know what each and every mathematical value shows. So there are problems on both sides. So what we require is an integration of these two. A science graduate or a researcher should have some idea about social science subjects or social science laboratory. Similarly, the social science students should have some idea about the mathematical principles, but without going for the complicated derivations. So, for the benefit of mathematics, statistics, economics, commerce, sociology, etc., I shall just go through which are the techniques borrowed from mathematics and borrowed from statistics, which are applied in social science. And those social science students who are representing me, don't be worried. I'm not going to have any complicated derivations or mathematical derivations. I'm just trying to link the basic ideas with the society. See, any mathematics student starts their learning of mathematics in 7th standard, 8th standard, 9th standard. Not only mathematics student, even social science students. Then there is a very, very simple mathematical principle taught in the 7th standard. That is, what is a mathematical function? So what I feel is the integration of mathematics, statistics, and social science really starts from here. What is a mathematical function? Then any student or scholar will easily write y is a function of x, a very simple mathematical function. But when we use this term, y depends on x, it conveys a lot in social science. It conveys a lot in social science. The real application of scientific tools in social science is linked to this. I can give you 2 or 3 examples. See, if you take one simple example from economics, y depends on x. You assume that y is demand, p is price. Then with these 2 terms, or we call it as variables, d and p, a lot of economic theories are explained, starting from law of demand. Then, if you come to sociology, you forget about economics. When you come to sociology, what is sociology? Social relations. Any sociology student or teacher starts, what is sociology? Social relations. Family relations. Then you come to another example. Education. In education, the ability of a student depends on, again it is a function, depends on a number, many variables. Even you come to chemistry, sorry, you come to history, we may feel that history is not a very important subject. That is a different issue, but still I'm touching on. So many people feel that history is not a good subject. And who prefers history? Keeping all respect towards historians, generally those who are scoring very less marks go for history. But I can just tell you, history is a very beautiful subject, a very beautiful subject, a powerful subject, provided we explain history in such a way. And there are mathematical models applied in history. There are mathematical models applied in history. A new branch has emerged, that is histometrics. In histometry, good amount of mathematical analysis has taken place. I can give you just one example. See, Second World War, First World War, frequent wars. There are some mathematical statistical analysis which explains it is the need of the time. In every time gap, there will be a natural problem, war or something like that. Of course, statistics is widely applied in medicine. So the simple idea, what we talk, what we learn in mathematics, functional relations. These functional relations, it is widely applied. It is widely applied in social science. Because social science is a set of relations, a set of relations. And to explain these set of relations, can start with a simple function. Y depends on X. Then of course it can be extended to any level. It can be extended to any level. So one tool, you may doubt is it a tool, Y equal to a function of X, but it is a very powerful tool. Number one. Number two, of course, algebra is widely applied. I'm not going to that. Algebra, whenever you do estimations, algebra is used. But I want to focus another area which is widely used in social science. It is differentiation, calculus, differential calculus. Now, why this differential calculus is used? It is more applicable in management as well as economics. Even in sociology, I have seen some models using differential calculus. Now, differential calculus, it is used with the two perspectives. One is optimizing a function. As all of you know, the very purpose of in the differential calculus, we think of optimizing. And mathematically, we put it as first order maximization. Optimization means maximization or minimization. Then there is a very important question. See, in economics, throughout we talk about maximization or minimization. In management, we talk about maximization or minimization. Today in management, differential calculus is widely used, not only for financial analysis, but even for productivity maximization, satisfaction maximization. Then in sociology, social relations, again we talk about maximization. So for optimizing functions, a social science scholar should know how the differential calculus is applied. Similarly, a science student, a mathematics or statistics student, who is absolutely thorough about the differential calculus should understand that we do all these differential calculus calculations, lot of properties, everything are there. then it is widely applied to the social science problems, which can be measured or which cannot be measured. So another area which is widely applied by social scientists today, it is differential calculus. See, the problem is a mathematics student just view a differential coefficient as just a derivative, dy by dx something. And for an economics or any other social science student, they don't know, even I have seen some students, they don't know how to write partial derivatives. They don't know, they may write derivatives dy by dx, but how to write a partial derivative, even they don't know. I have seen students find difficult just write to the delta. But these two are highly related. So a social science student should have fairly good idea about the entire differential calculus. It is applied in many fields, widely applied in economics, microeconomic theory, widely applied in management, widely applied in sociology. There are studies. Then a third area where a student of social science should be thorough, that is matrix algebra. See, when we look into the matrix algebra, why we have to learn matrix algebra, which is the basis of the computer algorithm also. When we come across large number of variables, when we come across large number of equations, it will be very difficult to solve. You take a very simple example. I'm taking a simple example only. If you are given two equations, what we call it as simultaneous equations. If there are two equations, in 7th standard or 8th standard, we learn how to solve these two equations and they get the values of A and B, two variables. But if the number of equations are more, if there are 3 equations you can manage, but if the number of equations are more than 3, it is impossible to do manually. Where we make use of the matrix algebra. And the students of mathematics, they are quite familiar with the Cramer-Rao rule for solving simultaneous equations. But it is widely applied. Where it is applied? Mainly in planning, number 1. Number 2, it is extended and applied. It is extended and applied in management. The companies, they are doing it. And today, there is a new modeling, not a new modeling, all these are outdated ideas, but we talk about these models only now. One is called structural equation modeling. Today, the social science scholars, particularly in commerce and economics, even sociology, they go for structural equation modeling. But the base of the structural equation modeling, interaction of large number of variables, numerous number of variables, it lies in matrix algebra. Whenever we come across unrestricted variables, number of variables are large and large and large, number of equations are large and large and large, definitely we can apply matrix algebra. So you're just, and of course, integration is also used. And I'm not going to details of that, but just for information. What is the difference between application of differential calculus and integration? If I put in simple words, in the case of differential calculus, from the total you are moving to the unit level, marginal level. From the total we move to the unit level. And the integration, the reverse. From the marginal we move on to the totals. So in this very quick time, I was just trying to familiarize, not teach, familiarize which are the branches of mathematics used by social science scholars. Which are the branches? You start with the basic idea of what is a function. Then you just go for the basic rules of algebra, what is called as law of indices, what you have studied in your school class. See, whatever we have learned in 8, 9, 10 classes, we cannot forget until our death. Not only mathematics, then English, and even social science, particularly mathematics and English grammar. These two portions are very, very important for any person. Need not be a mathematician, even for any other person, it is very, very important. So some branches of mathematics widely applied in social science. One is the functional relations, number one. Number two, the algebra, basic laws of indices. Then the third one, that is differential calculus and also matrix algebra. At least the fundamentals. A social science student should be thorough with these fundamentals. And of course, today, in many of the universities, these topics are included for social science students. So included for social science students. But the problem is, as I told you in the beginning of my presentation, the problem is the students of social science don't know why they learn all this. Then the students of science, they know all these things, but they don't know where to apply. And when I explain all these points, my humble request to the respected teachers from mathematics and statistics and also social science, if you are anybody attending me or listening to me, my humble request with the due respect is, when you explain these principles to a social science student, try to have the examples from the real life situations instead of going for abstract mathematical relations, so that a student will be able to know how these ideas of mathematics, they are integrated to the social science issues or social science problems. So I'm just trying to familiarize you which are the branches of mathematics applied in social science. Now let me move on to the second part, that is the application of statistical techniques. Now, in statistical techniques, which again, it is widely applied in all social science branches, allied branches. Again, just give you one simple example. See, now we talk about the COVID problem. And now there is a feeling that the days of COVID are over. But 3 days back, you would have read in newspaper, there is likely to be outbreak of COVID on 22nd of June 2022. See, exactly on 22nd of June, there will be an outbreak of COVID, which will be continued for next 3 years. 3 months, which I read in papers 2 days back. You forget about its relevance. But how they make these predictions? See, when we come to this area, two roles, which is important in social science analysis. One is estimation. Second one is prediction. Estimation and prediction. For estimation and prediction, We have powerful tools in statistics. We have powerful tools in statistics. And statistics is a subject. Those students of BSc statistics or MSc statistics who attend me, I can just tell you, you are in one of the beautiful branches of science. The wide potential for students of statistics, particularly, of course, others will be knowing, other students would have maybe also knowing. Today they're talking about big data, the then complicated system of data, how it is analyzed using artificial intelligence. So the role of the statistician, tomorrow the role of the statistician, and tomorrow the role of mathematician is going to multifold increase. Then students who are attending from economics or commerce, they may ask me a question, what about our future? Your future is also bright, because my point is, whatever be the subject you learn, you forget about the subject. What is more important is your competence in subject. Your competence in subject is very, very important. So I shall quickly go through which are the areas in statistics widely applied in social science. Now let me start with the simple ideas. As I talked about what is a function in mathematics. When you come to statistical application, the first powerful tool, the very powerful tool, that is graphs and diagrams. Graphs and diagrams. But unfortunately, because of the coming of statistical packages, today we don't give much importance for that. But it is very powerful. I can give you some examples. You go through newspapers. Sometimes if there is a major disaster, if there is a train accident, if there is an earthquake, whatever it is, some newspapers used to give the graphical representation of how it happened. The graphical representation of how it happened. I am not justifying that approach, but it shows the importance of graphs. Importance of graphs in every subject can apply this. Tomorrow, see, Kerala state is going to have the budget. Day after tomorrow, just look into the newspaper. You come across a number of graphs, pie charts, line graphs. Mainly they apply line graph and pie chart to explain the changes in the economic progress. Similarly in population, similarly in sociology, management, it is very important. So my point is, don't underestimate graphs and diagrams, because there is a very important purpose for that. What is the purpose of graphs and diagrams? It is illustration. To illustrate some ideas, particular to a common man, to explain some ideas to a common man, that's very important. These graphs are very, 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 very powerful. Another important tool, I'm touching only important tools. Next important tool, which has got some research relevance, that is measures of variation, measures of variability measures. Mainly, I touch upon two tools. One is the standard deviation and other one is the coefficient of variation. This is very important because what is the gap between two groups? The gap between two groups. In sociology, we have to study it. In economics, we have to study it. In psychology, we have to study it. You take two groups of students, or you take two villages. There are ample number of instances in the society where we should have some idea about what are the variation between different groups, different categories. Definitely, we can go for the measures of not measures under it is measures of variability, mainly standard deviation and coefficient of variation. And also to study the inequalities, a big area of research by the social scientists, inequalities, income inequality, uh, inequality between gender, men, and etc., etc., etc. You apply this variability technique. It is again a very powerful one. Then you come to third, next tool. It is very interesting. Correlation and regression. Correlation and regression. And when we talk about correlation, just from caution, I don't want to explain what is a correlation to you, but a caution. Correlation can give you unrealistic results. Correlation can give you unrealistic results. That is why we talk about the relevance of a regression. Because what is correlation? Relation between usually two variables. You relate two variables. One variable, number of babies born in Indian hospitals. Number two, second variable, number of deaths in the Ukraine war. Two variables. See, one is the number of babies born in Indian hospitals last week. Second variable, number of deaths in the Ukraine war. Next variable. Find out the correlation. Sometimes we get the correlation as 0.9, 0.8. Very, very, very high correlation. So even though correlation is very powerful, it may give you sometimes wrong results. And I have come across many research scholars who committed this type of mistake in correlation analysis. See, they calculate some values. This is the point where these two are related. They calculate some values, just explain the values purely based on mathematical value. But the reality may be different. The reality may be different. I shall give you another example. You take the rainfall in Kerala and you take agricultural production in America, two variables, you may get some high correlation. So correlation is very, very popular too, but it is not very dependent. But this problem is solved. This problem is solved with another technique, that is regression. Regression. See, you just take any study in any branch of social science, any branch of social science, you come across the wide application of regression. Wide application of regression. Dependent variable and a number of independent variables. But again, when you apply this regression technique, you have to be very careful, very careful. Unit of measurement is important. Unit of measurement. Otherwise, you'll be getting misleading result. I can just give you one of my experiences. Some years back, I got a PhD thesis for evaluation. In that thesis on poultry, chicken, there is a regression model. Dependent variable is egg production. Independent variable is quantity of feed given. See, dependent variable is egg production. Independent variable is quantity of feed given. You know what was the result? For producing one egg, chicken, poultry egg, you have to give 6 kilos of feed. 6 kilos of feed. 6 kilos of feed. Then, how it is possible? How it is possible? Just for producing one egg, which costs 2 rupees or 3 rupees, you are giving 6 kilos of feed, poultry feed, which comes around 20 rupees. You may laugh, but this really happened in a PhD thesis, which I evaluated. And you know what was of interesting finding? That is more interesting. This candidate, scholar, concluded that poultry farming is highly profitable in Tamil Nadu. Joseph thesis from Tamil Nadu. See, you forget about the mathematics. Just see the 3 points. Number one, dependent variable is egg. Second variable, independent variable is feed. And what her is conclusion? For producing one egg, you have to give 6 kilos of feed. And she concluded that poultry farms are highly profitable. This really happened about 10 years back. Then I asked this student, the Viva Vosi, how you got a result like this? How you got a result like this? You know what was his reply to me? She told me, sir, it was done with the help of a computer. It was done with the help of a computer. This point is very important. See, today there is a feeling for social science scholars. When you do something using a computer, your results will be perfect. Your results will be perfect. This is where we are going wrong. See, you keep one point in mind. Computer is a hardware. It doesn't have common sense. It is hardware. It doesn't have common sense. Whatever inputs you are giving, the computer will give output. So, if the computer doesn't have common sense, and the scholar also doesn't have common sense, net result will be nonsense exponential. Nonsense raised to some power. This is what exactly happened in the thesis. And this is the point which I want to focus or emphasize on you. When a social science student, scholar, applies these statistical, mathematical, etc. techniques, they should know what it is. Number one. Similarly, when a mathematics scholar or statistics scholar suggests a tool to a social science scholar, definitely you should have some idea about why I am suggesting this tool. Is it required for the scholar? Is it required for the scholar? Otherwise, we will be going wrong. So regression is very powerful, but you have to be very, very careful regarding the unit of measurement, selection of the variables, etc., etc., etc. So another one. Then another tool, which is, or another requirement in research for social science, it is sampling. It is sampling. And whether it is for a undergraduate project, whether it is for a postgraduate project, or whether it is for a PhD project, there is an interesting question. When the students present their study, suppose in the case of a PhD student, total sample is 1,000. I'm just giving an example. Total sample is 1,000. Naturally, there will be a question from the audience. Why you go for 1,000 sample? Why don't you go for lower sample, 250 or 300? Then tomorrow there is another presentation. Sample size is 250. 250. Again, the question comes from the floor. Why you have gone for a small sample? Why don't you increase the sample size to 1,000 or 1,200? See, these are some comedies. I put it as some comedies. These are some comedies going on in the discussion on sampling. And I can tell you based on my experience, I can tell you, to particularly the social science scholars, when we choose a sample, we have to follow some scientific principles. Some scientific principles are there. And in statistics subject, they have clear formulas, they have clear theories to estimate the sample size. So, my request to the research scholars, don't do sampling in a casual way. If we do sampling in a casual way, it will be leading to misleading results. Similarly, I have a caution to the science scholars who are recommending the sampling to a social science student. Whatever perfection you are expecting from a sample, theoretically, it is impossible in a social science sampling. That part is also important. Based on your statistical theories, normality, etc., 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 we can recommend samples. But that type of perfection cannot be expected in the real social science laboratory, that is society. So, on both sides, some compromises. How to compromise? Compromise considering the realities. Considering the realities are important. So, we have to, anyway, the caution when we go for sample, we have to be very careful. And there are a lot of bad practices. There are a lot of bad practices in sampling. And one bad practice today in social science research in Kerala, again, I am sharing my experience. It is, you are dividing Kerala into three parts. Many PhD students, they are dividing the entire Kerala into three: Northern Kerala, Central Kerala, Southern Kerala. What is the logic behind it? What is the logic behind it? I can understand, provided you are doing such a sample for agriculture, where the northern conditions will be different from southern. But there, the criteria is not this. In agriculture, we have to go for climatic zones. Okay, forget about it. At least the agriculture can think like that. But it's opposite to the income tax payment. Whether it is in northern Kerala or southern Kerala, rules are the same. So, similarly, there are a number of examples. Wide application without bothering any statistical principles. So, we have to be very careful. The statisticians and mathematics teachers have to give right advice to the social science scholars, considering the realities. That is again very important. Considering the realities, it is very, very important. Then, another area which is widely used by the social science, it is testing of hypothesis. Testing of another area where the social science scholars are really blind. Testing. See, and we apply a number of tests: t-test, chi-square test, f-test, etc., etc., etc. ANOVA, Mankova, Minikovas are there. See, if you just look into the literature of statistics, they give different tests for different purpose. See, and we apply these techniques, these sampling procedures, without knowing the fundamentals of testing hypothesis. The testing hypothesis actually starts with the formulation of null hypothesis and alternative hypothesis. And based on that, we have to proceed well. And what about the because it is very much associated to the normality theory. Then one tail test, two tail, of course, a number of statistical principles, etc., are there. Then the real problem, but again, I can share you my experience. Many scholars used to come to me. I'm totally worried, sir. Why? What is the problem? I started with an objective, or I started with some hypothesis, but unfortunately, I am getting a wrong result. Opposite, not wrong result, opposite result. Totally worried. My thesis work is totally waste. I have seen many scholars lamenting this to me. But see, they don't know the fundamental of research. They don't bother about the fundamental of research. What is the fundamental of research? We form a hypothesis, can either be rejected or can be accepted. Can either be accepted or rejected. 50-50. So if your null hypothesis is accepted, fine, don't worry. If your null hypothesis is rejected, again fine, don't worry. It all depends on interpretation. It all depends on associated dimensions of your study. So another tool which is casually applied, by social scientists, it is the testing procedures. Large number of tests are available in statistical literature. They are fine also, but we adopt them without any idea. The problem is social science students apply these techniques without knowing what it is. And what happens today? Whatever data you are having, you will be entrusting that data to a statistician or some of your friends who are familiar with the SPSS and all that. Then the problem is the statistician don't know what is your real requirement. The statistician don't know what is your real requirement. And you, the scholar, don't know which tool will be applied. So two wrong poles interact. Ill-informed statistician, and semi-knowledge scholar. Two opposite forces interact, leads to a big error in the result. So testing, sampling, all these are fine. But you have to be very careful when we apply all these tools. Of course, there are a number of other techniques also in statistics. And one area which I want to touch upon, where new research is coming on, particularly for the benefit of BSc Mathematics and BSc Statistics students. See, after your course, what is your plan? You may say, I will be going for MSc Mathematics, MSc Statistics, fine. But one area which is emerging, two areas which are emerging. One is research in demography. Because demography related to population and all that. Good amount of statistical modelings are taking place in demography research. An area which is emerging so fast today, it is demography. Only a good statistician, only good mathematician can outperform in demography. Similarly, another area which is emerging, it is big data and artificial intelligence. big data and artificial intelligence. And similarly, for those social science students who are interested in hardcore research, there are some institutes like IGIDR, then Matthias School, etc., where even Tata Institute. All these institutions are emphasizing research with the sound knowledge in mathematics and statistics. So I was trying to focus on how the statistical techniques are related to the social science problems. Then, when we talk about the statistical techniques, I was talking about descriptive statistical tools. Descriptive statistical tools. But we have the non-parametric statistics also. And today, the social science scholars widely use it. That's why I just thought of just touching it on what is called non-parametric statistics. What is non-parametric statistics? Which is used by the sociology, psychology, education, etc. See, what is non-parametric? Non-parametric means expressing our opinions. Expressing our opinions. Now, expressing our opinions like agree, disagree, likely, always, etc., etc., etc. This is called, and you would have heard about the very famous tool, what is called as Likert scale. Likert scale. And strongly agree, disagree, no opinion, etc. But again, I want to tell you, see, many scholars apply these techniques for the last 1 decade. But the problem is they do all these without knowing what it is. And this is a real problem today. The real problem of social science scholars, the problem is we apply many techniques. We apply many statistical techniques, mathematical techniques, without knowing what it is. And we are capable of applying it without knowing what it is because the computer packages are readily available. So what I feel personally is the computer has reduced the thinking process. The wide application of computers or over application of computers has reduced the thinking process. So I was just mentioning about the relevance of non-parametric techniques, which is widely used by the social science scholars in recent years. So with this time, I presented, see, one side is the mathematical techniques, which are the mathematical techniques widely applied in social science, I just touched upon. Then statistical techniques I just touched upon, and also the just mentioned about the non-parametric methods. Now, as I told in the beginning of my presentation, when we use the term quantitative techniques, I told you in the beginning, no one has a degree called a BSc or MSc quantitative technique. Then why with this term? Because it is an integration of mathematics, statistics, then comes OR, operations research, and all these are integrated with computer reasoning, artificial intelligence, big data, and all that. See, I just touched upon, I'm not going into details. What is OR? Operations research. Operations research, it was emerged in the 1940s. And it is widely applied by these management people, particularly in management. They apply these techniques. Anyway, I'm just mentioning the techniques only, not going into details. One is called linear programming. BSc students, MSc students, economics students, they learn linear programming, maximizing or minimizing subject to constraints. One tool. Second tool, that is the transportation models, which is very important in marketing, or today we call it as logistics. In logistics, it is important how to distribute a particular product to a particular point at lowest cost, transportation models. Then comes another tool, what is called as waiting lines, theory of theory of waiting lines, queuing models. See, I can give a simple example. You go to a post office counter, sorry, a railway station counter. There are 5 or 6 counters are there, but all the 5 are remain closed. Only one counter is operating, and there is a big queue in the railway station. Naturally, you may doubt why we require all these 5 counters, because all counters remain closed. Only one is open. There comes a question of the cost of employing 5 persons, the cost of employing 5 clerks, or the cost of doing everything with only one. It is again a question of optimization. Then there is another tool related to PERT, program evaluation review technique, something related to time management and so on. So then even dynamic programming, many programs are there in operation research. Operation research. Then in earlier days, it was impossible to do all these operations manually. But today means from 1970s onwards, we have computers. Laptops are there, palm tops are there, even smaller computers are there. And because of the coming of these computers, computer programs, packages, today, analysis is not a difficult task. So all these subjects, all these tools are developing like anything. Even today, you can do a mathematical technique without knowing what it is. I do agree with that. You can do it. But the problem is when we apply a mathematical technique without knowing it, you'll be misleading in your results as well as interpretation. So today, all social scientists are equipped with big kit, where we have the mathematical tools, statistical tools, quantitative tools, computer packages, plus, that is mathematical tools, statistical tools, operation tools, computer packages, plus little amount of nonsense also. Why I put like this, little amount of nonsense? Because without a proper understanding of this, we do analysis. One problem is our as I repeatedly told you in my presentation, social science scholars are not very thorough about the mathematics of certain tools. And mathematicians and statisticians are not very clear about the requirement of the scholar. So what we require, it is an integration. What we require is an integration between the scientific knowledge with the realities of life. With the realities of life. So you take variables. One variable is scientific knowledge, mathematical knowledge, statistical knowledge. Second variable, the hard realities of life. Now combine these two, we require integrated branches. Today what is required is integrated branches. And for the last 50 years, we have many integrated branches developed. One is econometrics, second one sociometry, third one biometry, fourth one psychometry, fifth one histometry, and so on. Many matrices are there. And of course, to do this research or to do studies in these matrices, econometrics, biometry, sociometry, etc., you need not learn anything new. A mathematics scholar can do it. A statistics scholar can do it. Even a non-science scholar can do it, because all these are old wine in new bottle. Just making some application, just like mechatronics in engineering. You know, in engineering, there is a branch for the last 10 years. They call it as mechatronics. What is mechatronics? It is mechanical plus electronics. The same thing in our subject also. Even in medical science also. Again, give one example. See, recently I read an article. I read an article. In that article, what is mentioned is today a good surgeon should have thorough knowledge in engineering rather than physiology. See, today a surgeon should have more knowledge in engineering rather than physiology because everything operations are keyhole or operations are using robotics, operations are using lasers. So how to make all these biomedical equipments? If doctor is successful in applying these biomedical equipments properly without knowing much about medical science, can be a good surgeon. The same problem here also. If you have some knowledge about mathematics, if you have knowledge about statistics, if you have knowledge about science, social science, etc., and if you properly integrate, if that word is very important, if you properly integrate, you can be a good analyst. You can be a good analyst. I underline you can be a good analyst. But a good analyst should be capable of applying these quantitative tools with a practical flavor. This word is very important. Apply the mathematical knowledge with a practical flavor. With a practical flavor. And I can just give you one example, and with that I shall stop because I know majority of the students attending me are from St. Aloysius College, and St. Aloysius College remains one of the, even now, one of the remote areas of Trachur. So whatever presentations you make, 3:30 is the cutoff. After 3:30, normally students will not be available. So keeping that, it's already 3:20 now. So just with the one example, I shall stop. See, all these 1 hour and 15 minutes, we were talking about the integration of statistical, mathematical knowledge with the social science. See, our Amartya Sen, all of you know who was Amartya Sen. When Amartya Sen got Nobel Prize in 1998, the press, Sweden's press, they asked him a question. What helped you to talk so beautifully on poverty? Because he was given Nobel Prize for his research on poverty, which he did in 1960s. Then this was the question: what helped you to talk so beautifully on poverty? You know what was his reply? I was born and brought up in Calcutta in 1940s when the Calcutta famine was the worst. All of you heard about the Calcutta famine, Bengal famine in 1940s. I was born and brought up in Calcutta in 1940s, and I grew up directly seeing and experiencing poverty, directly seeing and experiencing poverty. And this real life experience helped me to talk so beautifully on poverty, so beautifully on poverty. So this is what I told you, integrating scientific knowledge with the realities of life. You ask a scholar today, economics or sociology, what is poverty? I can very well tell you the scholar's reply will be poverty is a function of x1, x2, x3, x, for example. See the difference in the approach of Amartya Sen and the scholar. Today, the scholars are focusing more on the quantitative tools without knowing the realities. But Amartya Sen talked beautifully on poverty with his life experience. So what I suggest is a science scholar should have a flavor to the real life problems, and a real life and a non-science scholar definitely should have a good No, I don't say 100%, but at least some very good idea about the mathematics and statistical or quantitative techniques, then you can be a very good analyst. Can be a very good analyst. But when I put this last point, social science scholars, even teachers, may not agree with me because why they go for economics, sociology, BA psychology, economics, history, etc. They were afraid of mathematics. Why they are afraid of mathematics? Because I always blame your school teachers, not everybody, but the majority of school mathematics teachers who taught you mathematics in a very difficult way, who taught you mathematics in a difficult way. You just recall your school days. The terrorist in the school, it was the mathematics teacher. But those mathematics teachers who are listening to me, see, my feeling is you can teach mathematics or statistics or quantitative, whatever it is, in a very, very beautiful way. Because the foundation of all these subjects, mathematics, statistics, etc., it is logic. If you can deliver this logic beautifully, it will be very, very appealing to the social science. You would have heard about C.R. Rao, mathematics teachers and friends know about C.R. Rao. There is a very beautiful article written by C.R. Rao. His article is, title of the article is The Philosophy of Mathematics. Philosophy, an article written by C.R. Rao, The Philosophy of Mathematics, because mathematics can be explained without going for any derivations if you can apply logic. So you share this logic with the social science scholars, and social science scholars be clear about what is the requirement. And if you integrate these two in a very effective way, definitely we'll be able to have beautiful scientific studies relating to society, and hope this brief lecture will at least give you 1% motivation for better application of quantitative tools. Thank you.
Thank you very much, sir, for your great words and advice. Now it's a time for discussion. Dear participants, if you have any queries or comments on the session, you may please unmute the mic and share them. Sir, we have a question from one of the participants.
Okay.
I will just read it for you.
Okay.
So which statistical tool is appropriate to find p-value in a time series data?
P-value in a?
Time series data.
You can go for trend equations and get the p-value.
Okay, sir. Thank you. Sir, one more question.
Okay.
Can we compare regression results for different groups of data using any statistical tool?
Yes, there is a test called CHOW test, C-H-O-W, CHOW test.
Okay, sir. Thank you. So thank you, dear participants, for your queries and comments. Once again, thank you, Mani, sir, for the enriching talk. The chat box is flooding with words of gratitude for you. Dear participants, we have posted a feedback form in our chat box. Kindly fill the form out. The participation e-certificates will be issued within 2 days. I think we can wind up now. On behalf of Department of Mathematics, St. Aloysius College, I extend my sincere thanks to our resource person, Dr. K.P. Mani, Honorable Principal Dr. Chaku Jose, Head of the Department of Mathematics, Sri Jason Jacob, teachers, and all the participants for making the event a great success. Thank you everyone for taking time to be a part of this webinar. Have a nice day. Thank you.
Madam, can you share the link again?
Sure, sir.